All right, guys, let's do this unit test. I don't honestly know why I feel like doing this unit test um, on the video, because if I'm going to make a video, how to make it for the algebra group, because they're the ones that could probably use more help. But I'm going to do the unit test because this is what I feel more like doing for you guys, because I think logarithms are going to be a little bit more fun. Is that right? There's only 9 questions. That's not too bad for a unit test, right? Um, oh, but I've got to get my tool. This is the main thing. I want to play around with these tools on here. I think it remembered my size. Did it remember my size from last time? No, it's too fat. Is that too thin? That's all right. Okay. Oh, that color's terrible. That's good. All right. Let's do this. Let's see what it says here. 500 times, man, these are dirty. I'm better off with that. 500 times, I'm not better off with that. All right, I should have used my pause button, right? All right. Oh, gee, look what we got here. All right, well, let's go ahead and do this. Now that I see it, it's not quite as challenging as one might think. But we have 500 times 5y thirds to the y over 3 equals 1. Okay, first step, you want to divide that 500 out of there. So we've got 5 to the y over 3 equals 1 500th. Divided both sides by 500. Now I'm just going to, wants me to answer it to the nearest thousandth. So I'm solving for y is what I'm doing. And what this means is that the log base 5, base stays the same, of 1 500th equals y thirds. Then I just need to multiply both sides by 3 to get y. 3 log base 5 of 1 500th equals y. So I plug that into the calculator. Let's do it just straight. 3 times log. Oh, I'm not paying attention. All right, so I've got this in log base 5, so I need to. This is more challenging than it initially seemed like it was going to be. So I'm just going to use my change of base rule here. So I've got 3 log, this big one goes on top. 3 log 1 over 500 over log 5. So that's what I end up with there. The 3, of course, goes in the numerator. This would be 3 over 1 times this whole expression. So that just ends up in the numerator. You can do 3 times this whole thing, but you might as well just put it in the numerator. Change of base tells me that the base goes in the basement is how I remember that. So the big one here, the thing that is actually the log of something with this base goes in the numerator. Um, that's a good way to remember that, I think. I don't know. So now I can type it into the calculator if I can remember it. Oh, there it is. Oh, I've got to change to that. Okay, now I can do this. And I think I can move this over here. And so now I'm going to do 3 times log 1 over 500. Nope. I just do backspace. Yeah. 500 close parentheses divided by log 5 close parentheses equals. Did I get my equals? There we go. 3 times log 1 over 500 divided by log 5, and it equals negative. Let's write this down. Negative 11.584. I can remember that. I don't know. Negative 11.584. Okay, how do I clear those? Negative 11.584. Yay. Okay, rewrite the following in the form log C. All right. If I have this situation where I've got a log of something plus a log of something, same base down here, this is the log of this something times that something, right? So all I need to do is just write this as log 10. Right, and it's base 10 because there's no base listed there. Just log 10. Clear that drawing. Okay, a scientist measured the initial amount of carbon-14 in a substance to be 25 grams. The relationship between A, the amount of carbon-14 remaining in that substance in grams, and T, the elapsed time in years since the initial measurement, is modeled by the following equation. A, which is the amount, equals 25 e to the negative 0.00012 t. How many years will the substance contain? In how many years will the substance contain exactly 20 grams of carbon-14? So I'm going to write this like this. The one that when the amount is going to be 20 grams, right? So I'm going to replace the amount. A is going to equal 20. A equals 25e to the negative 0.30, 0.000. I'm running out of room here. 12t. 12t. I'm just going to write it like that because I ran out of room. And you guys can't see it anyway. I'm behind the... No, you can see it. Okay, good. So down here, I'm going to rewrite this as a log, right? This is the natural log because it's the... first, actually, I'm going to divide out the 25. So I'm going to have 20 25ths. I'm going to call that 4/5. Equals e to the negative 0.00012 t. E to the negative that thing is that. Now, if I write that as an exponent in exponential form, no, in logarithmic form, excuse me, then The base stays the same, right? This is what I'm looking at the base, the exponent or the log of, and the log is the exponent. So I write this log. Oh, wait, sorry. Natural log, because our base is e. Natural log 4/5, 0.8, let's call it. Natural log 0.8 equals negative 0.00012. And so then I just need to divide both sides by that. And then I can just cross that part out. And that just equals t. So I need to type into my calculator natural log of 0.8 divided by negative. Now, do they give me the calculator? That would be a problem. I can't do that in my head. Is that right? They're not giving me a calculator? That's not fair. All right. Um, all right. I've got natural log 0.8 divided by 0.00012. I think that's supposed to be a negative, but other than that, I think I remembered that correctly. Let's see. Natural log 0.8 negative 0.00012. Okay, I'm just going to throw the negative on there when we were done. And I get, well, that gives me a negative. So I'm going to take that negative off. 1859.53 if I'm rounding to the zero or to the thousandth. So 530, 1859.530. Oh, give an answer expressed as a natural logarithm. All right. I guess this is the good enough way to say this. Yeah. So I'm going to do negative natural log 0.8 over 0.00012. No wonder they didn't give me the calculator, right? Natural log 0.8 over 0.00012. I made that negative out there. 0.00012. All right. Good. All right, I'm going to pause for a second while I run across the room here. Pause, I'll be right back. Okay, I'm back. Oh, wait, what happened? Darn it, clicked the wrong thing. Resume unit test. Okay, and they moved me to the next question there. I was gonna, as I was thinking a minute ago, while I was paused, I realized that, of course, that answer had to be positive. It couldn't be negative. The thing turned out to be negative, but then it was a negative negative. So it turned positive 1859. I didn't write that one down, but I think it was something like 1859 years, because we wouldn't have the negative years if you were looking at the duration. All right, consider the equation negative 3 times e to the 5w equals negative 88. Solve the equation for w. Express the solution as a logarithm in base e. Okay. So the first thing we're going to do here is divide that negative 3 out of there. So I end up when I do that, getting e to the 5w equals, it's negative 88 divided by 3. Now, or I'm sorry, divided by negative 3. So I'm going to have 88 divided by 3. And I might as well, sorry, I've got to run over and get the plug. So many interruptions today. That didn't seem important enough to put the pause on, but I probably should have. Okay, there's that. I've got to plug this into my little Wacom tablet there. There we go. All right, that did it. I'm gonna loop this cord around behind me. All right. Now, where was I? E to the 5w. Oh, and I was going to do, I'm going to do that as 29 and a third. Yeah. Well, no, let's just do it as 88 over 3. Oh, it'd be 20. Yeah, 29 and a third. But 88 over 3. That's what we're going to do here. Oh, and so then they wanted to express it as a natural log. I don't know why they say logarithm base e. Normally what you hear is natural log if you're referring to that. So that means that e is the base in a natural log. So you don't need to write anything. Just write natural log. The abbreviation is ln because I think that it comes from the French rather than the Latin. And it's log naturel. I believe that's why it's ln, because in French they put the adjective afterwards. So this the natural log of 88 thirds equals 5w. But I'm going to say 1/5 the natural log equals w, because I'm going to divide out that 5 from the 5w. So if I'm going to express this like this, I could put the whole thing over 5, but I want to write it like that. There's no real great preference, but since it's a natural log of a fractional term, I don't know, it just looks a little bit nicer to me to do it this way. So let's see. 1/5. I wonder if I need to do a times. I'm going to try it without the times. 1/5 natural log 88. Nope. Backspace. Nope. Oh, maybe if I do that, there. 88 thirds. That's it, 1/5 natural log 88 thirds. Okay, once I got through the trick of typing that in, it was all right. Approximate the value for W round your answer to the nearest thousandth. This over, well, no, I'll do it there. This time, though, I'm just going to do natural log 88 divided by 3, and then that's divided by 5 equals 0.676. 0.676. Wait, how did that come back up there? 0.67676. There we go. All right, 1/5 natural log 88 over 3, 0.676. I guess I can 0.676 natural log of 88 thirds divided by 5. Looks all good. Get those off. Check that. All right. Okay. So here, the thing that a log is the exponent that you're raising this base in order to get that thing. So with this one, you could puzzle it out, but let's just go ahead and change it into exponential form and just say, okay, well, this means 27 to the x equals 1/3, right? Because the base stays the same. What the log of something equals is the exponent. And this is what you're finding the log of. So this base raised to some power equals that. That's how you flip those around. To solve this, I think the easiest way is to write this as 3 to the 3x, right? This is 3 to the third raised to the x power. The product rule tells you that you can then just do 3 to the 3 times x if you're power to a power. So 3 to the 3x, and this is 3 to the -1, right? Because that's a negative because it's down there, and it's 3 to the first in the denominator. It means 3 to the -1. That just means 3x equals -1, and then that means that x equals -1/3. And you can see that if I were to substitute this in, 27 to the -1/3, well, the negative puts it down in the bottom, and the 1/3 means the cube root of that. So you can see that works. 27 to the -1/3 does equal 1/3. Okay. So I need to get that there and type in -1/3. I like it better when they give me the little fractional thing. All right, which of the following is equivalent to, let's look at this, log of b base 3 times log 27 base b. Well, times log 27 base b. All right, so here we've got different bases, right? So I want to, I guess the easiest way to do this is to change the bases. So this one's log b over log 3, right? The base is in the basement. That's how I remember that. When I use the change of base rule, the base in the log is in the basement of the fraction. It works for me. And then I'm multiplying that times log 27 over log b. Well, notice, boom, boom, right? So I've got, when I multiply this, I get log 27 over log 3. Now, here, if I've got this, I can, let's write this in exponential form now. Is that what we want to do? Um, Is there an easier way? What's the way to do this? Well, if I've got these, we can look over at our rules here, and it says that if I've got which one? Do I want to go backwards on the yeah, I guess maybe the way to do this is to go backwards on the what you call it, the change of base rule. And if I can change this, change of base, if I can do that with the top up here and the bottom down there, then I could say, okay, well then this is log base 3 27, meaning what power do I raise 3 to get to 27? I guess that's the way to work with that. And of course, the answer is 3 here. So this is change of base rule backwards. Yeah, I think that's probably the simplest, straightforward way to do that. So I end up with A because that's going to be 3. The power that I take 3 to make 27 is 3. That's what the logarithm means. All right. Here's this. Okay, rewrite the following equation in logarithmic form. Let's see what we've got. 1,000 equals 10 cubed. Well, that's true. So then the log equals the exponent, right? So this just means log. Now it's base 10, but I don't need to write 10 when it's base 10. So log of 1,000 equals 3. The log base 10 of 1,000 equals 3, but I can just write log 1,000 equals 3. And this says rewrite the following equation in exponential form. This says log base 3 of 81 equals 4. Well, that means the base in either form, exponential form or logarithmic form, the base is the same. And just says that 3 to the 4th power equals 81, which you guys know is true. So this one, if they'd given us harder ones, maybe it would take a little bit more puzzling out. These are both pretty obvious because you know the answers to both of these. So that's my thought on that. Log 1,000 equals 3. And 3 to the 4th power equals 81. All right. I evaluate the logarithm. It says okay, so log 25 base 7. Well, I'm going to need to use the change of base rule if I'm going to evaluate with the calculator. So that just means log 25 over log 7. The base goes in the basement. That's the way I think of it. Log 25 over log 7. So then I just type that into the calculator. Find there. Oh, you might need a there, show calculator. Gee, you'd think I'd know that by now, how this thing works. Okay, so log 25 divided by log 7 equals log 25 divided by log 7. I typed that in right. 1.654. 1.654. 1.654. Let's just double check. Today. 1.654. 1.654. Okay. Clear those. And consider the equation 11 times 10 to the 5t equals 20. Solve the equation for t. Express the solution as a logarithm in base 10. All right. So the first thing we need to do for this is get my pen there. And I'm going to divide that 11 out. So I'm just going to rewrite this as 10 to the 5t equals 20 elevenths. Divided both sides by 11. And then I'm going to express it as a logarithm base 10. Well, first I'm going to express it as a logarithm. I'm going to say that this is the log, oh, that is base 10. Right, I'm already base 10 there. Log 20 over 11 equals 5t. I'm going to divide both sides by 5 to get t. This equaled 5t because that's the exponent. The log is the exponent. I just divided both sides by 5. So I've got that, and then they want me to type it into the calculator. So let's see. Let's go ahead and do the calculator first, I guess. No, let's just go ahead and type it in. Okay, so let's start with this 1/5. 1/5 log 20 over 10. No, 20 over 11. That's it. 1/5 log 20 over 11. And then I'm going to show the calculator. Try. There we go. And can I move it? Not very well. There. My machine's not working very well. I should have left it where it was. It's just easier. Okay, and I'm just going to type it in like this. Log 20 over 10. Over 11. Jeez, I don't know why I keep log 20 over 11 divided by 5. And I get 0.519. No, 0.052. 0.052. 0.052. Let's double check that. 0.052 rounded to the thousandth, and 1/5 log 20 over 11, because I rewrote that as it's base 10 already, and it's the log of 20 over 11 equals 5t. All right, I feel good. There we go. That is it. How did I make the time, I wonder? Let's see. 35 minutes. Not great. But you guys can watch that if you want. Well, by the time I've told you now, it's too late. You've already watched it, unless you fast forwarded. Let's get rid of those. Those make me uneasy. Leveled up on 9 skills. Nice, Joe. Okay, there we go.